All right, let's work on this in Visual Studio. Remember, we have 3 different tasks. One is to enqueue this, enqueue the request into the request queue. Secondly, we need to monitor the queue. Thirdly, we need to process the request. So 3 different tasks. So let's jump into Visual Studio. This is the one that we created for the single thread scenario, which is still relevant. We're going to keep this function as this, and we're no longer calling this function from the main thread. From the main thread, we still need a while loop, like an infinite loop like this, to enqueue the request. Here, we just listen to the input. And once we have the input, we enqueue the request into the request queue. Because of that, we need to create a queue. Let's go to the top and let's declare a queue. And we're just using a string inside the queue. And here we just create an empty queue like that. Now we need to perform the first task, which is to enqueue the requests. Here in the main thread, that's when we enqueue requests. That's the first task that it performs. So inside the infinite loop, if the user didn't type exit, then it needs to enqueue the requests. So the input queue, or maybe let's change the name to match the diagram that I provided previously. So I'm going to call it a request queue, and let's use this variable. And here we're going to say enqueue, and we provide the input into it. And that's everything we do in the main thread. The main thread is only handling this particular aspect. When the request comes, put it in the queue. Secondly, we need to monitor. And for that, we can provide a method. We don't necessarily need a static keyword like this. So we're going to say monitor queue. So here, basically, we need another infinite loop. So we cannot just monitor once and quit. And we need to continuously monitor. So when we look at the queue, we're going to say request queue. So if the count is greater than 0, that means there's some elements in there. Then we are going to first take that input out, right? So we take that input out of the request queue by calling the dequeue. And then we need to start a new thread to process this input. We cannot just directly call it like process input and provide the input this way, because if we do it this way, then the monitoring will be blocked by processing. Because we have those 2 different tasks. The monitoring and the processing are 2 different tasks. If we combine them, then the monitoring will be blocked by the processing. So therefore, we need another thread. So we're going to say thread. Remember how to declare a thread. So we're going to call it processing thread. And the thread will complete a task is to process the input, and then we just provide input like this. And right after that, we can start it. Now here, because a new thread is spin off, so this thread is not going to be blocking this while loop. So therefore, this while loop will go very fast, super fast. It's going to be super fast, which is potentially packing the CPU. So we don't want to add burden to the CPU. Therefore, I want to add a little bit sleep time for this. Let's add maybe 100 milliseconds of sleep time so that it doesn't bother the CPU that much. We don't want to consume all of the resources. So that's monitor queue, the second task. So the second task needs to be performed by another thread, because the main thread is working on reading the input from the user and enqueue that to the request. So the monitoring task will have to be performed separately from this. Otherwise, the enqueue task will be blocking the monitoring, and the monitoring again will be blocking the enqueuing. So we don't want to do that. Therefore, we will have to use a different thread to monitor the queue. But we cannot do it here because the code will never reach here. We cannot do it here because this part is the main thread. So we have to do it before we enqueue the request. We have to do it here, although this is the second one. So the second task is to start the requests monitoring thread, or the request queue monitoring thread. So we're going to have another thread. I'm going to call it monitoring thread and create a new thread, and the task is monitor queue. The monitor queue method doesn't take any parameters, so I can directly use it as a delegate. Now I can say monitoring thread dot start. Of course, when this just start, there's nothing in the queue. It will be 0. Therefore, it's going to just sleep for 100 milliseconds and then come back. While it's doing this, because it's started in a different thread, so it's not blocking, and we're going to directly go to the enqueue request task, which is waiting for the user to enter the input. Now, the first and the second task are done, and the third one is to process the input. We already have the method here, and that is already being called by the monitor task. Right here, we're performing the third one. So add a comment here and say third one is processing the request, and this is being done by a different thread right here. Okay, so we have 3 different tasks being performed by 3 different threads. Right? We have the main thread working on the enqueuing of the request. We have a worker thread working on monitoring the queue, which is this thread. And then we have the third thread, which is also worker thread working on processing. Now let's run the application and see the performance. Okay, it says server is running. Now if I say A and then hit enter, and it says process input A. So it still wait for 2 seconds, right? So because we have this 2 seconds. If I just do 1, it feels like the same as before. But if I continuously hitting the keyboard, so like this, then you see that they're being processed pretty quickly, one by one. And also our input is not being blocked. So I can do all of this all together, and then the processing is being done simultaneously. It's just that each process takes 2 seconds. That's why it appears to be slow, but at least it's not actually blocking the input, right? So the input is not blocking the processing is not blocking the input, and that's a simulation of a web server. One thing I need to point out before I finish this video is that we're using a normal queue. So this normal queue could be a problem in a real life scenario. If the enqueue operation here is in the main thread and the dequeue operation here is in the worker thread, if they're called in parallel, which they are, right? Here and here are using different thread. This is the main thread and this is the worker thread. It's possible that they're being scheduled by the thread scheduler in different core of the CPU. So at that moment, they are actually being run at the same time. That's true parallelism. So if they're really called in parallel, it can lead to a race condition and unpredictable behavior. This is because the regular queue class is not thread safe. So this is something we're going to talk about in the future when we talk about thread safe collections. But in this exercise, we can just use regular queue to implement this assignment. It doesn't really cause any problems because we are manually entering from the screen. Right? It's going to be, it is actually pretty slow. The chances for different threads to enqueue and dequeue at the same time are pretty low. So it's not going to be a problem. But when it's in the real world scenario where you have a lot of requests coming to the server, you have too many threads run at the same time, and there's always a possibility of enqueuing and dequeuing at the same time. And if you use regular queue, it might lead to unpredictable behaviors. And we're going to talk about synchronization later. Okay, that's everything I want to cover in this video. If you have any questions, please let me know. If not, I will see you in the next one.